let's talk about differentiation. Differentiation is part of calculus, and it's an important concept. There are two concepts, differentiation and integration, and it's the first half of calculus. And you will see that differentiation is all about rate. If you can differentiate an equation, you can find the rate of change of that equation. What do I mean by that? Let's say there's a line. Okay. What is the rate of change in a line? The rate of change in a line is equal to the gradient. Okay. Rate of change is equal to the gradient. Okay. In a line, it's easy to calculate the gradient because the gradient is constant. Use the formula you learned in algebra to figure out the gradient. Here I will just use the eye test and see that, okay, the rate of change or the gradient is at 1. Okay, I will just say m is equal to 1 right here. This is just an example. Okay. So in order to find the rate, you look at the gradient, you look at the tangent line, you look at the rate of change. Okay, now what happens if the graph gets more complicated? If it's a curve, it's harder to calculate the gradient. Okay, let's talk about parabola, quadratic equation. Okay, what's the rate of change here? Now it's much harder to calculate the rate of change. If you look at a point that's close to 0, let's draw a tangent line. Okay. If you draw a tangent line and find the gradient, that's the rate of change, right? If you look at point 0, if you draw a tangent line, you will draw an almost horizontal line. It's actually a horizontal line. And the rate of change would equal to the gradient, right? Rate of change is equal to gradient. And gradient is 0 in a horizontal line. Okay, so the rate of change is 0. What happens if you go towards the right? At this point right here, at the origin, it's at 0. But as you go towards the right and follow through the equation, the rate of change, or the tangent line, the gradient of the tangent line, and each point will keep increasing and increasing. And that's the definition of quadratic figure. And you will see that it's harder to calculate because the rate of change keeps changing. So how do you calculate rate of change here? You use differentiation. Okay. How to calculate rate of change in a curve? First, you differentiate. Okay. And then rest of the curriculum, you will learn how to differentiate different functions, and unfortunately, you're gonna have to be memorizing a bunch of formulas. And I won't cover the formulas for now, but just know that, let's say this is a quadratic, y is equal to x squared graph. Okay. If you differentiate, y changes into y prime. Notice the mark on top of y. And this x squared will change into 2x. Why? Because the 2 comes down, the power 2 comes down. It'll be the coefficient of x. And the power from 2, it'll drop 1. So drop 1 from 2, it becomes 1. 2 minus 1 is 1. So, and obviously 2x1 is equal to 2x, so I'll just erase the power of 1. So this is our differentiated graph. Okay. So this is y prime, differentiated graph. Okay. And then what happens here? you have to plug in the numbers in order to find the rate of change for each rate of change. Okay. Now, rate of change is not constant. Rate of change at this point, or the rate of change, or the gradient of the tangent line, is different at this point, this point, this point. In quadratic line, all points have different rate of change. So obviously, plug in different x value and you'll get a different rate at each point. Okay. So I'll give you an example. So what is the rate of change at when? Question. At x is equal to 1, what's the rate of change? What's the rate of change? Or what is the gradient of the tangent line? Okay. At when x is equal to 1, obviously the tangent line, this is a human error. Pretend this is a tangent line. What is the gradient of this tangent line? Or what is the rate of change at this particular point? Okay. So first we differentiate. Second, we plug in the x value. So we already differentiated. So this is our y prime. Y prime is equal to 2x. And second, you need to plug in the x value. At x is equal to 1, y prime is equal to 2x. In place of x, you plug in 1, so it's 2. So the rate of change, or the gradient, is equal to 2. Okay. So the gradient at this point is equal to 2. Okay. Now let's do this a few more times. How about when x is equal to 0.5 or 1/2? What's the rate? At when x is equal to 1/2, what is equal to what is the rate? And obviously, let's just plug in, get the y value. At when x is 1/2, y is equal to 1/2 squared. So it's 1/4. Okay, at this point, what's the rate of change? So first you need to differentiate, it's already done. Second, you need to plug in the x value to figure out the rate. Y prime is equal to 2x. So instead of x, you plug in 1/2. 2 times 1/2 is equal to 1. So at this point right here, I drew a tangent line. And at this tangent line, the rate of change is equal to 1. Okay? Does this make sense? I think it makes sense. Because as you go towards the right, or as x value gets bigger, the gradient is going to be bigger. It's going to the lines are going to get steeper, right? So it's 2 here, 1 here, and it'll gradually go lower and lower and lower until you get to 0. Now lastly, let's do at when x is equal to 0. What happens? What's the rate? Okay. So y prime is, in place of x, you plug in 0 is equal to 2 times 0 is equal to 0. So the rate of change is equal to 0 at when x is 0. So this is the line that's tangent at point x is equal to 0. This is the tangent line at when x is equal to 1/2, x is equal to 1. And the gradient here is at 2, gradient here is at 1, gradient here is 0. And this y prime is equal to 2x explains all the different rate of changes at each different x. Okay? Okay, so that's the whole concept of differentiation, and rest of the content, rest of the curriculum will be about differentiating different looking functions. Okay, so for example, okay, I just wrote y prime, but I will be writing many different notations. There are 3 different notations, okay? So I can say y prime if I want to express the derivative. Derivative and differentiation, they're the same thing. And dy over dx is also another notation of y prime, okay? And also, you usually write y as fx. F prime x is also another notation of this derivative, okay? Okay, and now let's look at power functions, okay? Power functions are defined as x to power of n, okay? And how do you differentiate this? You differentiate through a formula, okay? So just writing the notation. So d over dx is another notation of differentiating, and you will get n times x n minus 1. So what happened here? If you want to differentiate x to the power of n, it comes out as n times x to the power of n minus 1. What happened here? This power of n, it came down as a coefficient, and this power of n, it dropped 1, meaning it dropped 1 to n minus 1. So if the power was, for example, 10, it'll be 9. If it was 13, it'll be 12. Even if it was 11.5, it'll become 10.5. If it was negative 500, then what's n minus 1? Negative 501. So make sure you've memorized this form. Okay, we're going to solve different problems so you will memorize this easily. Okay, let's try a few examples. Okay. How do you differentiate x4? Okay. As I said, this 4 comes down as a coefficient and it'll drop 1, so it'll become 3. X to the power of 4 becomes 4 times x to the power of 3. X to the power of 6 becomes 6 times x to the power of 5, right? The power of 6, it comes down as coefficient, and the power drops 1 from 6 to 5. Okay, and now let's move on. What happens if x is equal to, let's say, 5.7? I didn't learn this. No, you shouldn't be saying that. Just follow the formula, okay? X 5.7, plug in n for 5.7, you get coefficient of 5.7, and you get power of n minus 1, so you get 4.7, okay? Just follow through the formula. What if you get x to the power of 1 over 2? Okay. Oh, this is fraction, I don't know. No, you should follow this formula. For in place of n, you get 1 over 2. So in coefficient, you get 1 over 2. And in the power, you will get x to negative 1 over 2, right? N is 1 over 2. N minus 1 is negative 1 over 2. Okay. So just follow through. This applies, this is exactly the same when x to the power is negative. I will just write a weird number, 100.1. What happens here? Negative 100.1, it'll come down. as coefficient, and the power becomes n minus 1. So what's negative 100.1 minus 1? It'll be negative 101.1. Okay. So this is how you differentiate the power. Okay. And let's talk about the scalar multiple rule. Okay. If there's a scalar, so what do I mean by scalar? If there's a coefficient, if there's a number in front of x, what happens? So let's say 5, 6 times x, 7 times x, 11, negative 909, okay? All kinds of numbers. Let's say 7.1 just to account for everything, okay? What happens here? So 5x to 4, this 4 you will combine with 5. So 5 times 4x3 will be equal to 20x3, right? 11x6 will be 11 times 6x5. 6x5.7 will be 6 times 5.7 x 4.7. So what do I mean by this? This scalar just comes out as scalar. It doesn't change. So when you do the power formula, when this 4 comes down as a coefficient, you will multiply 5 by 4. So it'll end up being 20x3. Okay, so just treat scalar as a scalar. Okay. Okay, next we have a little bit more complicated problems. Okay, y is equal to root x. How do you differentiate? Okay. I'll give you 15 seconds to think about it. Okay, if you're ready. Okay, so you can say, oh, we didn't learn this form. It's not part of the power, but it's not true. If you remember going back to algebra, we can express this as x to the power of 1/2, right? If it's a root x, this is x to the power of 1/2. If x to a third root, it's going to be x to the power of 1/3, and so on. Okay, should be aware of this, and using this fact, we can just use x to the power of 1/2, and we've already done this here, right? X to the power of 1/2 is 1/2 times x to negative power negative 1/2. Okay. Oh, we didn't multiply the negative 909, by the way. The answer would be just multiply this by negative 909, multiply this by 7.1. To simplify, you will be multiplying 1/2 by negative 909, but that's algebra, nothing to stress about. You should already be good at it. Okay, y is equal to root x, so x is equal to 1/2, so y prime in this case will be, okay, let's do this again, 1/2, this is the power. Power comes down as the scalar, so 1/2 times x to the power of n minus 1, n is equal to 1/2, n minus 1 is equal to negative 1/2. Okay, so this is our y prime. We can leave this as this, but if you want to take more time, you can rewrite this. Okay, what happens when you have a negative in your power? It means you flip the number. Is equal to 1/2 x to the power of 1/2. And what did we just say about power of 1/2? It means root. So we get 1/2 root x as your answer. Okay. This is a common form, so you will end up memorizing this actually after you solve problems and if you're confident, you will be able to memorize this later. Okay. Now let's try a worked example. Okay, so this is our notation. And this is the formula we just learned. Okay, differentiate 3x4 minus 1 over 2x squared plus 4 over root x plus 5 in respect to x. I wrote this too small. Okay. And to do this, we just follow this formula. Okay. And notice that scalar here is 3, scalar here is negative 1/2, scalar here is 4, scalar here is 5. This is just number by itself. Also, if it's the number by itself, when you differentiate, it just disappears. Okay, you just don't consider it. And notice the scalars, you just ignore it. You just multiply it to the upcoming coefficient that will come down. Okay, so the coefficient here is 3 times the power is 4. So the power will come down and you will multiply this with 3. So 3 times 4x, and from 4 it drops 1, so it becomes 3. So 12x3 minus, okay, now it's negative 1 over 2 over x squared. I will rewrite this so you don't get confused. Okay, so here I will just say 3 times 4x3. Here I will rewrite this minus 1 over 2 times x to negative 2. Okay, I just rearrange this algebraically. Okay, so negative 2 is the n. It comes down, you multiply with negative 1/2. Negative 2 times negative 1/2, it's plus 1. Plus 1 times x to negative 2. I will plus negative 2 times negative 1/2 times x to negative 3. Why is it negative 3 instead of negative 1? It's because you have to do minus 1. What's negative 2 minus 1? Minus 3. Okay. Should be simple. It's just a busy calculating exercise. Okay. And what is this equivalent to in terms of power form? Okay. The scalar is 4. And since x is in the bottom, it's negative. And we have a square root, so it's negative 1/2. Okay, so we use the formula here. Negative 1/2 comes down to the coefficient, so you multiply 4 times negative 1/2 times x to negative 3 over 2, right? Negative 1 over 2, plug it in. Negative 1 over 2 minus 1 is equal to negative 3 over 2. Okay. And I just said 5. You just get rid of it. 1, 2, 3, 4, 5. Any integer, any number, you just get rid of it, and you will get your answer to be this. Okay, so let's simplify. This is equal to 12x power of 3 plus 1 x to negative 3. Okay, so the coefficient is 1, so I don't need to write it. 4 times negative 2 is negative 2. Sorry, 4 times negative 1/2 is negative 2. So you get minus 2x to negative 3 over 2. Okay? So in calculus, you can write it in this form and it's perfectly fine, but if you just want to do the extra step, you can rewrite this saying 12x 3 plus, what is x minus power? Minus power means it's flipped. So it's 1 over x to the power of 3 minus 2. It's negative 3 over 2. So it means it's flipped. And it's 1.5, which means 1.5 in the bottom minus 2. Okay? But you can also rewrite this saying this is, okay, I'll just write the whole form so you don't get confused. As this, okay? You can stop here, but if you just want a more visually appealing answer, you can write this, but honestly, it's not necessary, okay? And also, if you want to go the extra mile, you can simplify this form. Make sure that there's no radical on the bottom side or the denominator side, but it's actually not relevant in this objective. Okay. Another example. Okay, this is a more application-based. What is the gradient of the tangent to the curve y is equal to x, 2x minus 1, x plus 3 at 0.14? Again, the question is asking, at this graph right here, and at this particular point on this graph, what is the gradient of the tangent curve? Okay? Gradient of tangent curve, that's rate of change, and that's differentiation. It's literally asking you to differentiate this. Okay? Okay, we don't know how to differentiate this, so we will do the FOIL method. We will multiply all three factors and simplify and make it into the power form. Okay, let's start with 2x minus 1 times x plus 3. 2x minus 1 times x plus 3 is 2x times x, 2x squared, minus x, 2x times 3x, 2x times 3, 6x, minus 1 times plus 3, minus 3, and times x. Okay, so let's simplify 2x squared plus 5x minus 3. So this is just algebra, don't get upset. 2x 3 plus 5x squared minus 3x is our equation. Okay, so this is our y and we need to differentiate. So let's differentiate. Y prime is equal to, so this is what we just learned. What is our n? N is 3. So 2 times 3 is our coefficient. 2 times 3, 6. X, from 3 it drops 1. Power is 2. Okay. Scalar 5. 5 times the power 2, 10. The power of 2 drops 1, so it's 1. But power of 1, you simply don't have to write the power, so it's 10x. And minus 3x. 3x, it's in fact power of 1. Okay, so power of 1 times negative 3 is negative 3. And power of x, the power of 1, it drops 1, so power of 0, it's just x to 0. So it's minus 3. Okay? And this is not the end. We need to calculate the rate of change at when x is equal to 1. Okay? The value of x is the important part. So let's plug it in. 6 times 1 squared times 10 times 1 minus 3 is equal to 6, 10, 16 minus 3 is 13. Okay? This is just mostly algebra. You should be able to follow through. The only part we learned today, brand new, is this one. From here, the original equation, we learned how to differentiate the power form. So from here, we got to this form. And after we get the differentiated, after we got the derivative, we can plug in the x value, 1, and calculate the rate of change of when x is 1, or find the gradient of the tangent line at when x is 1, and that is 13. Okay. And rest of the questions, they're just application of this. Sometimes you do this backwards, sometimes you hit word problems. But the main focus is about, if you want to find the rate of change, you need to differentiate and plug in the x value. And how do you differentiate? In this power form, you differentiate using this formula. Example 7.4 says ax4 plus bx squared plus x. It's a curve and it has a gradient of 3 when at x is equal to 1. And when x is equal to -2, the gradient is equal to -51. And find the value of a and b. Okay? So it's exactly the same problem, but the problem is that instead of getting a real number, a real scalar, we got a variable. So even though it's a bit more awkward calculating using variable, it's exactly the same process. Okay? Y prime, let's differentiate. Power of 4 comes down. 4 times a is our new scalar. And from 4, drop 1, 3. 2 comes down as scalar. 2 times b times x. Power of 2, drop 1, it's 1. Okay? And x to the power of 1 we can just ignore. And x1 is just simply 1, right? So power of 1 comes down to 1, so it's 1. And then power of 1, drop 1, 0, and that's just 1. Okay? So now let's look at this. We have two cases. In this y prime, first we can plug in the value of x is equal to 1. And y prime will be equal to 3. Okay? Let's do this. Let's label this 1, let's label this 2, okay? According to this, y prime, okay? Remember y prime is equal to the rate of change or the gradient of tangent line. And the gradient of the tangent line, it's already given by the question, it's 3. 3 is equal to, in place of x, you plug in 1. So 4a times 1, 2b times 1 plus 1 is equal to 3. 2, the rate of change is -51, is equal to -4a times -2 to the power of 3 plus 2b times -2 plus -2. Okay. Let's rewrite this second equation. Okay. -2 power of 3 is -8. -32a minus 4b minus 2 is equal to -51. Let's add 2 on both sides. -49 is equal to -32a minus 4b. And let's rewrite the equation A. 4a plus 2b is equal to 2. Okay. And look, this is a system of linear equation. You should already know how to do this from GCSE. Okay, let's just go through it. Let's multiply 2 in the equation. 4 is equal to 8a plus 4b. Okay, and we have negative 32a minus 4b, so we will add the two equations. So add them, negative 49 plus 4 is negative 45 is equal to negative 32a plus 8a is negative 24a. Negative 4b plus 4b is 0. So a ends up being 45 over 24. Simplify, we have 15 over 8. Okay? And b, you can plug in the number and get your own answer. I did the math wrong here. Oh, sorry. In place of x, I should be 1. Okay? Okay, I saw this one and assumed that I needed to plug in negative 2, but I needed to use the y prime equation. Okay? So if you do the math again here, instead of having 49, you will have negative 50. Okay? And then instead of having 45, you will have negative 40, something doesn't add up. Sorry, it should be negative 52. Okay. Negative 52, and then you get 48. Okay. There were some minor algebraic calculation mistakes, but the method's consistent. All you need to do is follow this formula and just say, okay, look at the power, look at the coefficient, and just, okay, the power is 4. It comes down to the coefficient, to the scalar, and the power, it drops 1 to become 3. So that's the main course objective in this lesson. Okay. Okay, next we're going to talk about the chain rule. Okay. So when you differentiate, you say, okay, if you find the derivative over x over y, it's the same thing as when you take derivative of x relative to u times derivative of u relative to x. Okay? And if you look at this algebraically, makes sense, right? Du cancels out, and you're left with dy over dx. This is an important concept. So it says, example 2 says, find the derivative of y is 3x minus 2 to the power of 7. Okay? So we're going to treat this 3x minus 2 as a completely different function. Okay? Let's say u is our 3x minus 2. So we're going to substitute u. Okay? So what happens? Y is equal to u to the power of 7. Okay? Makes sense. So let's differentiate y using u. So this is the notation. We're differentiating y using u. So method remains the same. 7 comes down, and from 7 it drops 1, so power of 6. Okay? But now let's differentiate this. Okay? U is now our y. We're going to treat this as our y. And we're going to differentiate it along with x. Okay? 3x minus 2. Okay, minus 2 becomes 0. 3x, it's just 3. Right? Just follow through the formula. So you have two derivatives. And we want to find out dy over dx because this is our original equation. We want to find the derivative of y in terms of x. But here we use substitution, so we instead of doing derivative of x, we did derivative of u. Here we did the derivative of u relative to x. Okay, follow the formula. What's dy? Okay, dy over dx is equal to dy over du. Substitute 7u6 times du over dx 3 is equal to 21u6. But in place of u, we will plug in 3x minus 2. So this is our formula. Sorry, this is our answer. Okay. So this is the chain rule. So here, it's kind of complicated. If you wanted to use the previous method, you would have had to multiply the 7 factors, all of them, and that's a long, tedious work. So instead what we did was use the chain rule and treat the 3x minus 2 as one variable, like u7. Okay, and you can easily differentiate u7 because that's just a formula, 7u6, easy. But you have to differentiate u in terms of x as well because of the chain rule. Okay, and we have 3, and you just simply multiply the two functions. Okay, so it seems like, so this doesn't make sense initially, but just do the problems, just accept the fact that chain rule exists, just follow through the formula, and you will get used to it. From what I remember when I was a student, I don't think I understood what was going on. I just did it mechanically. Okay. Okay, now let's move on to another problem. This one's a little more complicated because it involves a fraction. Okay. Find the derivative of y is equal to 3x squared plus 1, 5 over 2. Okay. From the formula we know from the power differentiation, we have no idea what to do about this. So we need to use the chain rule here. And what do we see here? We see the 5. So if we treat this as one variable, this differentiation is going to be so easy. Okay. So we define u as 3x squared plus 1. Okay. Let's just start with dy over du. Okay, let's rewrite this. Okay. Y is equal to 2 over u5. So dy over du is equal to, so it's technically 2 times u, negative 5. So power of negative 5 comes down. What's 2 times negative 5? Negative 10. U to power of negative 5, it drops 1. Now it becomes negative 6. Okay, so this is dy over du, our first part of chain rule. Now second part of chain rule, du over dx. It's this one. We need to differentiate this. Du over dx is power of 2 comes down, 2 times 3, 6. Power of 2, drop 1, 1. And we can just ignore this. Plus 1, we can just delete the 1 and we get 6x. Okay? And chain rule, apply them. dy over dx is equal to dy over du is negative 10 u negative 6 times du over dx is 6x. Okay? It's easy to stop here, but you shouldn't be stopping here because the question doesn't define the u for you. You define the u, so you need to let them know what u is. Okay, so let's plug in. What is u? 3x squared plus 1 times 6x. Okay. If you want to simplify, you can put this in the front, negative 60x times blah. Okay? Okay, so the rest of the problems, it's about identifying the functions, identifying which expression you want to substitute as to make the calculations easy. So the chain rule is basically for you to utilize to make the calculations easier. Technically, you don't need it if you are confident in just differentiating straight. Okay. Another problem. This is more of a quiz instead of asking you to differentiate. The curve y is equal to root ax plus b passes through the point 12, 4 and has gradient 1 over 4 at this point. Passes through 12, 4 and at when x is 12, gradient is at 1 over 4. And we need to find the value of a and b. Okay? So we have two variables and we have two informations. Okay? So it's system of equations with two variables. So let's just plug in. In place of x, plug in 12. In place of y, plug in 4. Okay, 4 is equal to 12a plus b. Okay. And n is 14, so we need to differentiate this. Okay, so we use the chain rule to differentiate this. Y is equal to, let's say ax plus b itself is equal to u. U is ax plus b. Y is equal to then u to power of 1 over 2. Right? The square root is equivalent to having power of 1 over 2. Okay? Let's differentiate dy du. It's 1 over 2, power comes down, u, and 1 over 2, drop 1, it's negative 1 over 2. Du dx, it's easy, it's just simply simply a. Okay? Multiply the two, dy dx is equal to 1 over 2, u negative 1 over 2 times a. Okay? So, when x is equal to 12, and the y prime is equal to 1 over 4. Okay? Let's plug back in ax plus b into u. Times a. Okay. So let's plug this in. 1 over 4 is equal to 1 over 2 times a times 12, 12a, plus b, negative 1 over 2 times a. Okay? So multiply 4 on both sides, you get, I will multiply 2 on both sides. You get 1 over 2 is equal to this. Okay? And this is a complicated, seems like a complicated problem, but if you solve through the equation, in the end, this is just algebra, you will get a and b to equal to 2 and negative 8 respectively. Okay. What is important is applying the chain rule, recognizing which expression you're gonna be representing u as, okay, to make sure that the calculation makes sense, to make sure that you apply the power differentiation. Okay? Yeah, we'll stop here. Okay. Next class we will be doing tangent line.